And now we're on question 8, and we have 8.1 saying, determine f prime of x from first principles if f of x is equal to 3x squared plus 2x. Okay, so this is the part of the paper that you can really just score marks. It's 4 marks. So first of all, before even writing that formula down, it's best to start with that f of x plus h so that you already know what that is. So remember, this just means wherever you see x plus h, wherever you see x, replace that with x plus h. So over here we have 3x squared. So we're going to say 3, and then in place of x is x plus h, all squared. Then plus 2, in place of x, x plus h. And this will give us 3, and then we still have inside this bracket. Remember how to work this out. Instead of writing the bracket twice, you square the first term, that's x squared. Then you take the first term, multiply by the second term, that's xh, and you times that by 2, so that's positive 2xh. Then we have plus h squared, because we squared the last term. Close bracket, we can multiply this in already, so we have plus 2x plus 2h is equal to, then we're also going to FOIL this in as well, so we have 3x squared and plus 6xh, and lastly plus 3h squared, and all of this just follows. Okay, now that we have the f of x plus h, we can go ahead and write the formula. The formula is just that f prime of x is equal to the limit as h tends towards 0, and we have f of x plus h minus f of x all over h. Okay, keep writing that limit of h tending to 0. Then we have the f of x plus h, because that was the f of x plus h. Put all of that in. So we have 3x squared plus 6xh plus 3h squared plus 2x plus 2h. So just be very careful in this one and just try to avoid making mistakes. Then we're going to subtract it by f of x. Now the thing about subtracting it by f of x, and something you can do just so that you don't have to keep rewriting things, instead of just saying minus, then you put brackets and then 3x squared plus 2x, because then you're still going to have to FOIL this in and rewrite all of this again. Something you could have already done is known that this is going to have a minus and then open brackets, meaning this negative is going to multiply to whatever that was and whatever that was, meaning now you just have a negative 3x squared, and again multiply that by a negative, that same negative, negative 2x. So just always multiply those by a negative if you want to avoid putting brackets and FOILing in. Okay, then we have over, we have h. And then another thing that you will also notice if you've been working with these the whole time is that these ones, the ones that you're subtracting by, they're the only things that will cancel over here. So that's what you have to search for. I see minus 3x squared, I'm going to cancel 3x squared with that. Then I just have to search for a minus for 2x. It's going to cancel with that one. So there's 2x, it cancels with that. And then everything else is just left. We have is equal to the limit as h approaches 0, and we have 6xh plus 3h squared, then we have plus 2h all over h. And then this is equal to the limit as h approaches 0, and we're going to now have to get rid of or take out a common factor of h so that it can cancel with this h and we do not have this becoming undefined. So we're taking out the h as a common factor and we're opening a bracket. Then we're just going to have, remember, just saying this divided by this, the h's will be gone and you'll just be left with the 6x. And then this second term plus 3h squared divided by h, one of the h's would cancel and you're left with positive 3h. And then the positive 2h divided by the h is gone and you just have a positive 2 all over an h. Then your h's cancel and you are left with this. Now, you don't have to rewrite this lim if you're going to substitute h already. So I'm just going to do that. I'm not going to rewrite this because I'm going to substitute in place of h. So I just have 6x plus 3, and in place of h, we're putting 0. Then we have plus 2 is equal to 6x, and we have that becoming 0, and we just have a plus 2. So that is the derivative of that function. That is the gradient of that function at any point. Okay, so we have that. Something you can also do just to check that it is correct, you can derive that from the rule. So the rule would say 3 times the 2 would give you 6, and then you have your x. Subtract 1 from your exponent, it would give you a 1. You don't have to write that 1. Then you're going to say the positive 2 times the invisible exponent of 1, that gives you a positive 2. Then that invisible exponent of 1 minus 1 just gives you 0. X to the power of 0 is 1. So 1 times the 2 just stays the 2, and that's why it just stays positive 2. So that's another thing you can do just to check that your answer is correct. So we do get the same thing, and so that's fine. Okay, next question. Okay, so 8.2 says determine dy over dx if y is equal to 4 square root of x minus 8 over square root of x plus pi x cubed. Okay, another thing to just look at here, and I think if students looked at this question at first, they would have gotten afraid of the pi. Pi is just a number. That's just something you should remember. Treat it as the number that it is. Okay, so when deriving, before even deriving, you need to prepare your function to be derived. First of all, we know that if you are deriving, you shouldn't have square roots. Okay, so we should not have any square roots. We should also not have anything on the denominator. Move anything that is an x, a variable, to the numerator. So that also needs to go on top. So first, let's work on getting those square roots not to be a square root anymore, but instead we will have it raised to an exponent. So this is what we can do. So we're still saying y is equal to, and so I have the 4. So instead of saying square root of x, you're going to just say put down x. And when we're looking at a square root, there's actually an invisible 2 here, but we don't really say that. So we have square root of x, and on top of the x, there's a natural exponent of 1. You always leave the x like that, and you say it's the inside exponent over the outside exponent. Okay, so it's in over out. And that's how we'll put it as not a third anymore. So x to the power of 1 over 2. So as a rational exponent. Then we have the 8. We can also just do that to that square root over there first. So we have minus 8 over, that is also square root x. So it will become x to the power of 1 over 2. And then we have, of course, the plus pi and x to the power of 3. Okay. Now the next problem that we have is this. That should not be on the denominator because it's an x. It needs to go to the numerator. When you're taking this and putting it on the numerator, the consequence is that your exponent will become negative. So that's what we need to remember there. So y is equal to, we just have the 4x to the power of 1 over 2 minus, now we have 8, and then we're going to put the x on top, but the exponent now becomes negative 1 over 2. Then we have plus pi x cubed. Okay, so now our function is ready to be derived. So when we're deriving, we're saying dy over dx is equal to, you're going to take coefficient times exponent. So 4 times a half, that's like saying a half of 4. That is just going to be 2. We have x to the power of a half. Then you have to say minus 1. So a half minus 1 will be a negative half. So negative a half. Then we have negative 8. Always take the sign in front of it. It's a negative 8 multiplied by a negative a half. Negative times negative is positive. And 8 times a half, it's like saying a half of 8. That is 4. Then we have x to the power of negative a half minus 1. Same thing as saying minus 2 over 2. And that's going to give you a negative 1 minus 2, negative 3 over 2, because the denominators stay the same. And then we have a positive pi. It's a number. We're saying positive pi multiplied by 3. And that would just give you a positive 3 pi. And then we have our x to the power of 3 minus 1 would give you 2. So there we go. That's it derived. Okay, then when we have it in this form, now we have to just put it in a way that the exponents are positive. So remember, you only move what has a negative exponent. So we're saying just dy over dx is equal to, The 2 has a natural exponent of 1, so there's nothing wrong with it. So we leave 2 where it was. And the x to the power of negative 1, that will go to the denominator. It's currently on the numerator because everything that is just written like this is naturally already put over 1. So we need to put that on the denominator. It's x now to the power of positive a half. And then with the 4, the positive 4 is fine. It has a natural exponent of 1. We only take that to the denominator. So x to the power of positive 3 over 2. And then lastly, this one, the exponents are not negative, so it's fine. Positive 3 pi x squared. Okay, so that is your final answer. You can put this back as surds, but that's really unnecessary. They would still accept this answer. Okay, so question 8.3, it says the graph of g of x is equal to ax squared plus b over x is equal to 96. Has a minimum value at x is equal to 4. And you have to calculate the values of a and b. Okay, so with this question, I feel like there is a problem with the way they wrote this, because they're saying g of x is equal to ax squared plus b over x. Then they're saying it's equal to 96. So I think they mean that this is the function's equation, but they're also saying that g of x is equal to 96, which probably means the y value is 96. Okay, so they're saying that the y value of this function is 96, but this function also has a minimum value at x is equal to 4. So when we have a minimum value, that's a stationary point that we have. So if we have a stationary point at x is equal to 4, then that just means that at that point, the gradient is going to be 0. Okay, so this is how I would go about working out this question. Because we have g of x, first of all, let's start with, it's going to be a simultaneous equation because we need to solve for a and b. So we're going to have g of x is equal to ax squared plus b over x. Because they gave a minimum value at x is equal to 4, I'm going to find the gradient of this function at x is equal to 4. Okay, because it's a minimum value, I know the gradient already. So to find the gradient, we're going to derive this function. But it's not ready to be derived because we have an x on the denominator. So we need to get that x on the numerator. So I'm rewriting it as g of x is equal to ax squared. And then we have plus b. The x is going to the top. And because it's going to the top, remember, its natural exponent, the natural exponent of x is already 1. So when it goes to the top, you're going to have a negative 1. So you have x to the power of negative 1. Okay, now it's ready to be derived. And when we derive it, we're finding the gradient. So I'm saying g prime of x is equal to, so I'm saying a times 2, which is 2a. And we have x to the power of 2 minus 1, which is just 1. I don't have to write the 1. Then we have a positive b times negative 1, and that will give us a negative b. And we have x to the power of negative 1 minus 1. So if you say negative 1 minus 1, you're going to get negative 2. Okay, so this is the gradient. This is the equation for the gradient of this function at any point. But because x is equal to 4, that is a minimum value. A minimum value is a turning point or stationary point. And at the stationary point, the gradient of a function is equal to 0. And remember, gradient in this case is that g prime of x. We know that this should be 0 where x is equal to 4. So that's what I'm going to say. First of all, let's substitute where x is equal to 4. So I'm saying g prime of, and in place of x, 4 is equal to 2a bracket 4 minus b bracket 4 to the power of negative 2. And this will give us, so now I also know that g prime of 4, okay, the gradient at that point where x is equal to 4, that gradient is 0 because it's a minimum value, a stationary point. The gradient at all stationary points is 0. So 0 is equal to, and so 2a times 4, that's 8a. And then we have negative b, but let's just calculate that part first. So 2 to the power of negative 2 is 1 over 16. So that's negative b, and I'm going to put that as, that's 1 over 16. If you're saying negative b times 1 over 16, then negative b times the 1 will multiply, and then this is put over 1. 1 times 16 is 16. So I can just rewrite that as negative b over 16. Okay, so this is what we have so long. Then I'm just going to take the b over, that over, since it's negative. So we have now positive b over 16 is equal to 8a. Then the b looks much more easier to make a subject. So if we need to get rid of the 16 so that b can be left alone here, we would have to multiply both sides by 16. And now we will just get b is equal to 8a times 16. 8 times 16, that's 128. So 128. Okay, and we have a, of course, 128a. So I'm saying that this is my first equation. That's the first equation I formed using the information that they have given. The second information we can form is probably because of this 96 now. Remember they said g of x is equal to this function, then is equal to 96. So I'm assuming they mean g of x is equal to 96. And if they're saying g of x is equal to 96, g of x stands for a y value. So that is the y value. That's 96. And they told us it has a minimum value at where x is equal to 4. So it must mean the x value is equal to 4. So I can substitute this as a point into this equation of g of x. Okay, so now that we know the x and the y value, we're going to substitute it into our g of x equation. But let's go ahead and just update the equation because we know what b is now. It's 128a. Okay. G of x, the equation of g of x is equal to, it's just the ax squared. And then we have this plus, the b is now 128a. So 128a over the x. Okay. So in place of x now, I'm going to substitute 4. And so I'm saying we're having g of 4 is equal to, then we have a bracket 4 all squared plus 128a over 4. So we've substituted a into this. Okay, then we just have g of 4. G of 4 is actually 96. Since that's the y value, it seems like that's what they're saying is the y value. So g of 4 is 96 is equal to a, and then that gives you 16. So 16a. Then we have plus 128 divided by 4. So if you say 128 divided by 4, we get 32. So plus 32a. And so these a's can go together. If you say 16 plus 32, that just gives you 48. So 96 is equal to 48a. And if we divide both sides of the equation by 48 to solve for a, we're going to get that a is equal to 96 divided by 48 is 2. So a is equal to 2. So now we know the value of a. Okay. To find the value of b, we can just substitute a into that. So b would be equal to 128 multiplied by 2. So in place of a, I'm putting the 2 that we found. So b is equal to what is 128 multiplied by 2, and that gives you 256. Okay, so that is the value of a and b, it seems like. Okay, so that concludes it for 8.3. Then we can move on to the next question, question 9. So now we're on question 9, and question 9 says, the graph of h of x is equal to negative x cubed. So notice there actually is a number in front of x cubed. It's negative 1. Plus ax squared plus bx plus c is sketched below. So they give you a and b, and they say that they are turning points of h. So they give us that as 6 and 0. Then they also tell us that t is a point on h. We have been given the x value of t, and the graph of h passes through the origin. So the origin is also another point that we have there. As you can see, it is an x-intercept. It's also a y-intercept as well. So that tells us a lot. The first question, 9.1, we need to show that a is equal to 12 and b is equal to negative 36. So for this question, I'm just going to fill in b. B was, so we don't forget, that was 6 and 0. And that origin, you know, it's 0 and 0. So to find a and b, let's see what we can use. From the graph, we know what the coefficient in front of x cubed is. But also remember, because we know what this is, we know that the graph passes the origin. It means that its y-intercept is 0. This is also an x-intercept, but we know definitely the y-intercept is 0. So this already tells us the value of c. So we know that c is equal to 0. Okay, so c is equal to 0. Okay, so that is the value of c. But now, based on the way this graph looks, there is another easier way to actually solve for this. Remember that this is a graph that has an x-intercept that is also a turning point. The equation of this graph in the x-intercept format would look like this. So whenever you have x-intercepts, we have two x-intercepts here. We have one here and we have one here. You can use the x-intercept formula of this, so the format of a cubic function. And that is y is equal to, we have the a first, open bracket x minus x1, and then x minus x2, and that one is squared. The one that is squared belongs to your stationary point that is also an x-intercept. So that one. Okay, so what we can do is, we know what a is in this form. It's not this a, okay? This a is this a is referring to the one in front of x squared, okay? That number in front of x squared. This a that I'm referring to here, that refers to whatever is here in the cubic function. So your cubic function, the general equation looks like this. Y is equal to ax cubed plus bx squared plus cx plus d. This is the a I'm referring to over here. Okay, and I'm saying that the value of that a, as we can see over here, there it is. It's -1 because we have negative x cubed. So that a is -1. So I can fill that in there. So I'm saying y is equal to the -1, and then we have x minus our first x-intercept. So this is the normal intercept that is not also a turning point. And that intercept would be here. The x value, okay, that is a 0. So I'm going to say x minus 0, and then open another bracket, x minus the x2, that would be the turning point that is also an x-intercept. And that one, the x value of that is 6. So minus 6, close bracket, all squared. Okay, so let's just solve for what we can here. Here we have y is equal to negative, and we have x minus 0, which is just going to give you x. So it's negative when we times in by x, and then this. So I'm going to open up a bigger bracket so we can just simplify this. Remember, with this, all you have to do is square the first term. That's x squared. Then first term times second term. That's negative 6x. Then times that negative 6x by 2. That's negative 12x. Then square the last term, negative 6 all squared. That's positive 36. Okay. Then over here, I can just go ahead and say negative x multiplied by the x. That's going to give you, so y is equal to, you just have a negative x being multiplied by all of this, x squared minus 12x plus 36. Then I'm going to just FOIL in. So I have this times that, which gives me y is equal to negative x cubed, and then again multiplied by the second term, that is positive 12x squared, and then by the last term, which would be negative 36x. And then now if you compare this to the equation we had above, you would see that, so I'm just going to rewrite this equation so we can just see what a, b, and c are. Okay, this was what h of x was. So as you can see now, look at the order it's in. We have our negative x cubed. Then you can see now that positive 12, that is your a value. And negative 36, that is your b value. And c really is equal to 0. Okay, so remember, they only asked you to find a and b, but we do know c is equal to 0 because that was a y-intercept as well as an x-intercept. So it means that, therefore, a is just equal to 12 and b is equal to negative 36. Okay, so that's how to find a and b. Then moving on to the next question, 9.2. So the next question, 9.2, they want you to calculate the coordinates of A. So A is a turning point. So you just have to find the coordinates of a turning point. To find the turning point, you're going to have to take the original equation and derive it. So we have It was h of x. We have h of x is equal to negative x cubed, and our a is now positive 12x squared, and then our b is negative 36x, and our c is 0, so you don't even have to write it. So we have this, and we have to find a, which is a turning point. To find the turning point, just derive this. So to derive it, you're getting the gradient. So remember, we're deriving it just so that we can find the gradient of this function. So h prime of x is equal to, and so we're saying this negative 1 times 3 is negative 3x minus a 1 that is squared. Then we have positive 12 times 2, which is positive 24. X to the power of 2 minus 1, which is just 1. We don't have to write that 1. And then negative 36 times 1 on the numerator, on the exponent here. So that's negative 36. And we just have, of course, that will fall away because x to the power of 1 minus 1, that's just x to the power of 0. Anything to the power of 0 is 1. This 1 is just multiplying by that and staying the same. Okay, so now that we have this is the gradient of this function of h. Since we want the turning point, we are finding the gradient, okay? But we know what the gradient is at the turning point. At every turning point, the gradient is always going to be 0. So we're going to make h prime of x equal to 0, since this is the equation of the gradient. So we have negative 3x squared plus 24x minus 36. As you can see, this is something we have to factorize, but also notice there is a common factor of, I would say, negative 3 all through. So we're going to divide both sides by negative 3 just so that that can be positive. And we're going to get 0 is equal to that. That's going to give you x squared. 24 divided by 3, that's going to give you a negative 8x. And negative 36 divided by negative 3 is a positive 12. Okay, so now that we have this, we can say 0 is equal to, open up two brackets, and we're saying x and x, factors of 12 that can give us a negative 8. Because the 8 is the only negative one, the middle is the only negative and everything else is positive, both these brackets are going to get a negative. So looking for factors of 12, then when you add them, you're going to get 8. So that can be 6 and 2, because if I say negative 6 minus 2, I get negative 8. And if I say negative 6 times negative 2, I get positive 12 at the end there. So that worked out fine, and now we can just solve for x. So it means that x is either equal to 6 or x is equal to 2. So these are our two solutions, but remember, we want b. We already know one turning point. That's the 6. So we're only going to accept the 2. Let's work with the 2. So we want the coordinates of a, so we need to get the y coordinate as well. We have the x coordinate. To find the y coordinate, you take 2 and substitute it into the original equation, not the gradient. The gradient one only tells you the gradient, doesn't tell you a y coordinate. So we're saying h of 2 is equal to negative, open bracket 2 to the power of 3 plus 12 times 2 power of 2 minus 36 times 2. And let's see what this will give us. And when we put that into the calculator, just make sure you put everything in properly. Just be very careful when you do this. You get negative 32. And that makes perfect sense. It's negative because you see the y value is negative. So we know this one now is 2 and negative 32. Okay, so that is the value of a. Make sure you always conclude because they ask you for the coordinates. So conclude a is 2 and negative 32. Okay, so that is 9.2 done, and then we move on to 9.3. So 9.3 says calculate the value of y. So we have to find y. Okay, so y was the y coordinates of t. Okay, so we have 3 and y, so we just have to substitute the x coordinates into the original equation of h, and we'll find y, the y coordinate. So since h of x, or h of x was equal to, I don't actually have to rewrite that. See, here's the equation of h of x in the previous question. So instead, I'm just going to substitute 3 because t was just 3 and y. So h of 3 is equal to negative, open bracket 3 all cubed, plus 12 times 3 all squared minus 36 times 3, and then we close the bracket. And let's see what that gives us. And as you can see here, h of 3 is negative 27. So that is our y value. So it means that y is just equal to negative 27. Okay, so I always just try to answer exactly what they asked for. They asked for y, tell them what y is. Okay, and that's just for 1 mark. Moving on to 9.4. 9.4 says, is the graph of h concave up or concave down? So concave up or concave down at the point T. So show all your calculations. When we're speaking about concavity, let's look at what we have to look for when you're finding things about how the graph is concaved at specific points. So if you have a cubic function, something like that, for example, when you're looking for how it is concaved, it's just speaking about how it's curved. So like a parabola, you have two types of parabola, one concave up and one concave down. It's the same thing here. So if you can look at it, you see that this part here, that's the concave down part. And then this part over here is concave up. But then we would need to know, where exactly does this start? So, okay, cool. I know that this part is concave up, but like, where does that start? Now, that starts at the point of inflection, So if the graph looked like this, whatever the x value of your point of inflection is, this part of the graph is concave up. It would mean that whatever the x value is, let's say it was 2, right? You would be able to say, okay, it's concave up at the point where x is greater than 2. So we can see over here, it's all concave up because these are all values that are greater than 2. That's if x was 2. And it would be concave down for where x would be less than 2. That's where it would be concave down. So if they're asking for a specific point, let's say they were asking for 5 and 5 is over here, and you're asking, is it concave up or concave down? Well, this falls in the region of where it is concave up. So at where x is equal to 5, it will be concave up. So let's answer that question for what they actually asked us for in the graph. So at the point of t, let's see if it's concave up. We know what t is. We know the x value of t is 3. So is it concave up here? Now, you cannot just assume that it's concave down just because it looks like that. You can't just assume that. So it means that you actually have to find that point of inflection because you don't know where it changes concavity. You don't know where it changed from concave up to concave down. So let's find that first, that point of inflection. Then we'll be able to judge whether it is concave up at t. So to find that point of inflection, or really just the x value of the point of inflection, we're going to take the equation of h. Let me just write that down. Then we're going to derive it. Okay, so derive it the first time. So we derive it twice. First time we get negative 3x squared plus 24x minus 36. To get the point of inflection, you derive it twice. So second derivative, then we have negative 6x plus 24 when we derive it twice. Then you're going to set that second derivative and make it equal to 0. So 0 is equal to negative 6x plus 24. Because the 6 is negative, I'm just going to go ahead and take it over so it can become positive. So we have 6x is equal to 24. Then we divide both sides by 6 to solve for x. And we find out that x is actually equal to 24 divided by 6. I think that is 4. Okay, so yes, it is 4. So x is equal to 4. So now we know where the concavity changes. Let's mark that place on the graph. So on the graph, the concavity changes at the point where x is equal to 4. And that already doesn't look right. 4 can't be here. So looking at this, I'm just trying to pinpoint where 4 is. I'm just going to assume this t is this over here. So let's say this one was 3. Then after it is 4. So here is our 4. Let's say this is where it changes concavity. 4. The graphs are never really drawn perfectly and to scale and stuff like that. So if it changes concavity here, this is what this means. It means that all through here, you see it's curved up. All the way from here to where the x value is 4. That is concave up. And all the way from here, after the 4, all the way down, that's concave down. So it means that 3 would not fall within the concave down region. It's in the concave up because it's not even past 4. We have 3 here. The point of inflection is at 4. So where t is, where the x value is 3, your graph is still concave up. So that's a way that you can answer that. The graph is concave up. So it just means that the graph is concave up at the point t, because x is equal to 4 is your x value of the point of inflection. And you can see it did not go past that x value. Okay, and then 9.5 is determine the coordinates of the point of inflection. Okay, now about this, because it's 2 marks, I feel like they might not have wanted you to find this about the concavity this method, because you see, using this method, you found the x value. We will find the x value, because you see, using this method, we would already find the x value of the point of inflection. So if they only gave 1 mark, if we know what the x value is, to find the y value, we would just have to substitute this into that equation. So I find it weird that if they only gave us 1 mark here for doing that, because we knew what 3 was and we just put it into this, then I feel as if this one might only give you 1 mark. So something you can do is show how you found the x value of the point of inflection. That would also mean that there's also another way of doing this. And there's another way of actually finding out whether something is concave up or concave down. And so let me put the second way of doing this. So for this one, we will just need the equation of the second derivative. So of course, we will find the second derivative just like we did here. So I'm not going to rewrite that. I'm just going to put that down, only the equation of it. So I also like to add, this is why it's also very important to look at the next question before actually doing the question you're doing, just to check if there are alternative methods of working through this question. Okay, so this is how to see how it is being concave. We can just go ahead and substitute. We knew that t was 3 and y, but we found out what y is, but we only need the x value. If you want to find out whether it's concave up or down at this point, just substitute 3 into this equation, the second derivative's equation. So if you say f double prime of 3 and we have is equal to negative 6 bracket 3 plus 24, let's see what we get. And you see, we get a positive 6. So we get h prime double prime of 3 is equal to positive 6. If your second derivative is positive here, it's greater than 0, it means that the graph is concave up at this point. If it gave you a negative value, to be concave down. Now, please also take note, this is not the same thing as finding out whether there's a local minimum or local maximum. That is a different situation. In that case, local minimum and local maximums are turning points. The higher one is the maximum. The lower one is the minimum. In that case, I know there's also a second derivative test that we use to test whether it's going to be a local minimum or maximum. This is a different test entirely. In this test, you would have to put in the x value of that turning point. That is a different case to this. This 3 is not a turning point. It doesn't belong to a turning point. So when you substitute any other x value on the graph into the second derivative's equation, it will tell you the concavity at that x value. But when you are speaking about specifically the turning points, it will tell you whether it's going to be a maximum or minimum. And this is how this one works. Let's say this over here is x1, right? And this one is x2. If you wanted to find out, is there a maximum at this point, you would substitute like this. We would say h double prime of, let's say we substitute x1. Now, this one, if it was a maximum, it will give you a value that is smaller than 0. That would mean you have a local maximum. If it was a minimum, when you substitute x2, you would get something greater than 0. That means you have a local minimum. This is different because we are specifically using the x values of the turning points. Okay. But in this one, 3 is not a turning point. It doesn't belong to a turning point. It's just a random point. So that will tell you how it is concave. If it's greater than 0, it's concave up. Smaller than 0, it's concave down. So it just means that the graph is concave up at the point T. So for 5.9, where we have to determine the coordinates of the point of inflection, we're just going to take the original equation and derive that to find the point of the x value of the point of inflection. So if you derive that h prime of x, then derive it again to get the second derivative, that's negative 6x plus 24. Then equate that second derivative to 0. So 0 is equal to negative 6x plus 24. And then take that over. So 6x is now equal to 24. You need to solve for x, divide both sides by 6, and x is equal to 4. So we have the x value of the point of inflection. We just have to find the y value because we need to get the full coordinates. Okay, so to get the y value, substitute 4 into the original equation. So h of 4 so that we can find the y value. Negative 4 all cubed plus 12 times 4 squared minus 3 times 4. And for h of 4, we get negative 16. So it just means that your point of inflection is just 4 and negative 16. And that is the last question in 9.5. Okay, so now we are on question 10, and question 10 says, a hotel has 72 rooms to let to clients. The daily rent per room is 500 Rand. If the rent is increased by 100 Rand per day, 2 rooms can be left vacant daily. The rent is X Rand per room per day, where X is greater than 500. So 10.1 says, show that the total daily income I is given by I is equal to 2x minus x squared over 50. Okay, so let's just read into what is being said here. So this hotel has 72 rooms to let to clients, and the daily rent is 500 Rand. And this rent is going to keep being increased by 100 Rand every day. And while the rent is being increased, 2 rooms are left vacant daily. Okay, and now they are saying that the rent is X Rand per room per day, where X is greater than 500 Rand. And we basically have to find the total daily income. So you have to look at this as if you own a hotel. If you owned a hotel and you wanted to calculate your total daily income, you find your income by basically saying, what is my rent? How much am I charging per room? Multiplied by the amount of rooms that have been rented. So these are the two factors we're going to look at. We're going to have to look at the rent per room versus the rooms that have been rented out. So let's look at the rent per room. Remember that they said that the daily rent per room is 500 Rand. And then, so it's basically starting at 500 Rand. And if the rent is 500 Rand, they also tell us that a hotel has 72 rooms. So this is where it has not been increased by 100 Rand yet. So where the rent is 500 Rand, the rooms available is 72. Then they tell us if the rent is increased by 100 Rand per day, 2 rooms can be left vacant. So 2 rooms will be left open or empty, meaning a total of 70 rooms have been rented. So it looks like this. We have 500, now it's being increased by 100. And so what happens here is you have your 72 rooms minus 2. So 70 rooms are now going to be rented. So from this, it's kind of like saying, if I wanted to calculate the total income, if the rooms were 500 Rand, then I'll just say 500 times 72. And that would be the price. If I wanted to calculate the rooms, if the rent was this 600 Rand, then I'll just say this 600 Rand multiplied by the 70 rooms available, and I would find that. But the thing here is that they're not saying that the rent is actually a specific price. They say the rent is X Rand per room per day. But before actually looking at that, let's just see the pattern that this keeps creating. Since this part keeps increasing by 100 Rand, the next time that we increase the price again, so when we're increasing the price for the second time, or let's just look at it as the third day after the price has been increased, it would be plus 100 Rand plus 100 Rand. So the previous price plus another 100 Rand. And the rooms rented would look like this. It's the 72 rooms minus 2 of the previous day, then minus an extra 2. So if you look at the rent per room, you see that it's creating a pattern. It's creating a pattern that we can actually sum up like this. We're saying this is 500 and then 500 plus 100. And I'm actually going to say times 1 instead. And then instead of saying plus 100 here, I'll just say plus 100 times 2. So you can see these numbers now are going to start representing the day after the increase. So this is the first day after the price has been increased, the second day after the price has been increased, and this affects the rent, the price of the rent per room. Likewise, I can also do the same to this part. Instead, I can say 72 minus 2 times 1. That was the first day after the increase. And then instead of saying 72 minus 2 minus 2, I can just say 72 minus 2 times 2 instead. This is the way the pattern looks because 2 rooms keep being deducted. So looking at this, we can actually just create a formula because you can see it's a pattern. It's a pattern that is increasing constantly by 100 Rand. We can actually create a formula for this rent per room. So what is actually going on is that we have 500 Rand plus 100 Rand, and then you see that these keep increasing. This is the day of the increase. I'll see it as 1 here stands for the first day of the increase. Then 2 would be the second day of the increase because then we're increasing it by second 100 Rand. So I'm saying 500 plus 100 multiplied by the specific day of the increase. And likewise, the rooms rented can also have a formula. It can also just be, as you can see, it's also doing the exact same thing. This formula or this pattern keeps decreasing by 2. So we can say that it's actually 72 minus 2 multiplied as well by the specific day of the increase. But now if we read into this question, they are giving us a specific rent. We don't have to now guess of which one we're going to take, which particular rent. They said the rent is X Rand per room per day, where X is greater than 500. So when they're saying X is greater than 500, that is really kind of their hint of telling you that it is definitely not this day. We cannot calculate the total rent by saying 500 times 72 because X is greater than 500. So definitely there's been an increase in the day that they are referring to. So the rent on that day is X Rand. And of course the rooms will be calculated still by saying 72 minus 2 multiplied by that specific day of the increase, whether it's the first, second, third, fourth. So looking back at our whole goal of this, finding the income, the total daily income, this really just means that the total daily income is going to be found by saying, again, it's still the rent per room, but in this case, we know that the rent they're speaking about is X Rand. So that would be the X multiplied by the rooms rented out. And that would be this formula, 72. So multiplied by the 72 minus 2 times, I'm just going to use big brackets here, times whatever day of the increase that they are referring to. So that being whether it's the first day of the increase or the second day of the increase or the third and so on. But the reason we cannot calculate, we cannot just give this as the formula is because, as you can see, the formula looks nothing like that. So we actually have to find, it has X, it has numbers in it, but it doesn't have this day of increase. So we actually have to find the formula for the day of the increase. So notice that this day of increase is included in the rooms rented formula and it's also in the rent per room formula. But let's look in the information and see how we can actually create a formula from this. Remember that they said that the rent is X Rand per room per day. If this is the formula for you to get the rent per room per day, and they're telling us that the rent itself is X Rand, we can equate this formula with X in order to find the day of increase and put that as a subject. So we're simply just going to say the 500 plus 100 times the day of increase, that being the formula for your rent per day. We're saying that that is actually equal to X because that's what they told us. They told us that X was the rent per room per day. So we're going to equate that with X. And now all we have to do is make this the subject. So to make this the subject, notice the 100 is being multiplied by this. So we need to get rid of the 500 first. So we can take the 500 over, and what we're going to have here is 100 multiplied by the day of increase. And that will be equal to, we still have the X here, then minus 500. Then to make this the subject, that day of increase, we can divide both sides by 100. So divide by 100 and divide by 100. And what we're going to get is that the day of increase will be equal to, so we have, I'm going to split this formula by saying x divided by 100. That's just x over 100. And then negative 500 divided by 100, and that will be negative 5. So that would be the formula for the day of increase. And now we can go ahead and use our total daily income formula and just substitute in place of day of increase. We can substitute this because this will tell us whether it's the first day of increase or the second day of increase and so on. So here again is our formula for the total daily income, and in place of day of increase, I'm just going to substitute this x over 100 minus 5. Okay, so let's go ahead and simplify this. So it just means now that our income is going to be equal to, we still have the x, and then it's being multiplied by, let's sort out what's inside here first. So we just have 72 first, then the negative 2 is going to multiply by the x, and remember the negative 2 is really on the numerator, so it's like negative 2 times x, which is negative 2x over 100. And then we have negative 2 multiplied by negative 5, which will give you a positive 10. Okay, then we can go ahead and just put the 72 and the positive 10 together since they're both numbers. So we have that our income is equal to x multiplied by 82 instead minus 2x over 100, but that can be simplified as well. So if you say 2 is common in 2 and 100. So if I scratch out 2 here, 2 divided by 2 is 1, but there's an x, I can just leave that as x. And then 100 divided by 2 is going to be 50. So we just have over here an x over 50. Then lastly, this x is going to multiply into these two numbers. So we have x multiplied by 82. So our income is equal to 82x. And x multiplied by negative x over 50, which will be negative x squared over 50. And that's how we get the income. And remember, that is the answer for 10.1. Okay, so that's our answer. And now moving on to 10.2. Okay, so 10.2 says calculate the maximum daily income per room. So the maximum income per room. We already know what the daily income is. This is the daily income per room. So we just have to find what is the maximum value of this. To find the maximum or minimum value, you have to derive this equation and then set it equal to 0. And of course, you can think about it as if it is a curve, right? This case, this is clearly a parabola because it has x squared, the highest exponent is x squared, and then we have an x over here. And you see that in front of the x squared, we have a negative, okay? So it's definitely a concave down parabola, and we're just trying to find that, the turning point. So you're finding the turning point, and we can see this is a maximum turning point. Okay, so we're finding this maximum. So it's also, just remember, it's also, we're just finding the gradient. When you derive anything, you're finding the gradient of that function at any point, but we're trying to look for where exactly is the gradient equal to 0, because only at the turning point your gradients would be 0. So we're deriving this. So I'm just going to say I prime is equal to, and if you derive, now there's a way you can just, before actually doing that, there's a way you can rewrite this so that it doesn't look as confusing as it is. So we have 82x, that one is fine. But this one, we have a minus. Think about the number you have in front of x squared. There's actually an invisible 1. So you could have written this as minus 1 over 50x squared, because the x squared is on the numerator. So if you look at it like this, it's really like x squared over 1 being multiplied by this. So when we multiply it, it would have been negative 1 times the x squared to give you the negative 1x squared, and the 50 times the 1 to give you the 50. So you can separate it like this. Okay, so there's your fraction and there's your exponent. So now we can derive. So I prime is equal to, I'm saying the 82 times the exponent of 1. So it's 82. And then, of course, the x to the power of 1 minus 1 just gives you x to the power of 0, which gives you 1. So 1 times 82 stays 82. Then we have the negative 1 over 50. So negative 1 over 50 being multiplied by the exponent of 2. So times 2. And that gives you a negative 1 over 25. and then x to the power of 2 minus 1, which is 1. We don't have to write that. Now that we have derived it, this is the gradient of this parabola. We want to find the turning point or the maximum turning point. So this is going to be 0. We have to make the gradient equal to 0 and say 82, then minus 1 over 25x. In this case, I would rather just put the x on top. It's just easier to solve like this. Since this is negative, I'll take it over. So this is x over 25 is equal to 82. Then we just need to solve for x by multiplying both sides of the equation by 25. And so x is going to be equal to, what is 82 multiplied by 25? It's 2050. So it means that x is just equal to 2050. That would be the x value of the maximum daily income of this. Okay, so that's just the x value. If you're looking at it as a graph, the x value was that 2050. They didn't really ask you for, oh, they did. Okay, they asked you for, calculate the maximum daily income per room. So they are actually asking for the maximum daily income. So they want the y value. This is just the x value belonging to this maximum turning point. We want the y value as well. Okay, so we need to find what that y value is. Simply just take the x value that you found here, substitute it into your original incomes formula, and you'll be able to find the y value. So remember, the income formula looks like this. And so now we're just going to find out what exactly is that maximum amount. So I is equal to, in place of x, because this is just the x value belonging to the maximum value. Okay, so we're putting 82 and then in place of x, 2050 minus, and then that's going to be 2050 all squared, then over 50. And let's see what that gives. Okay, so remember they said that x was really just the rent. That's what they called x. They said it's the rent per day. But the total income is not the rent per day. That's how much they've made in total based on what the rent for that day was. So that the total income would be 82,050 Rand. That would be the total income. So in this case, that's what they're asking for, the maximum daily income. So that is the maximum daily income. The maximum daily income is that. So that's the maximum daily income. Okay, so that's just something that you need to be careful about. Remember, this formula only gives you the total daily income. The X is the rent on that specific day. So we know this was the rent, okay? And then the total or the maximum daily income would have been this amount, because you have to take it and put it back into the equation. It's like finding the y value. That was the x value, but 84,050, that was the y value. I said 82,000, 84,050. So that is the final amount. Okay, so that's it for question 10. And then we're moving on to the last question, question 11.